So in topic, we are going to discuss about what are partitions in the topic, what are offsets in the topic, and what is meant by a topic replication factor. And in the broker concept, we are going to discuss what is meant by a broker in Kafka and how does a broker holds a topic. Like whenever we create a topic, how the topic will be handled by the broker. How does the backend file system will be allocated to the topic. A topic, this word topic is a very powerful word in Kafka. So without topic, there is nothing you can do in Kafka. So let's understand about the internals of topic now. So a topic is particular stream of data. It means the data stream will happen between sender application and the receiving application via this topic only in Kafka. So topic is base of everything in Kafka. In Kafka, so everything based on topic only. Like when our application people want to communicate with other application, so the sending application will connect to Kafka, put the message into topic inside Kafka, and the receiving application connects to Kafka and it will connect to that particular topic and it can consume the messages. So that's why this topic is called as particular stream, and this topic is base of everything in Kafka. So without creating a topic, you can't establish a communication among the applications. So we can compare a topic with a table in a database. Like you must listen about a database and you must listen about a table in the database. So what does a table contains in a database? Some data. It could be anything. Same thing, a topic in Kafka, it contains some data. So like a table in a database contains some data. In the same way, topic in Kafka contains some data. Like whatever the data that is being published by producer application, that will be stored in Kafka topic, and whatever the data that is being consumed by the consumed application, that will be consumed from the topic only, because in Kafka, topic has the only ability to store the data, like the messages. So you can have as many topics you want. Like in one Kafka cluster, you can create n number of topics. Absolutely, there is no limit. So your Kafka cluster could be a single node Kafka cluster, or it could be a multi-node Kafka cluster. It doesn't matter, but you can create n number of topics. So topic is identified by its name. So every topic is having a unique name in one cluster. So topics are again split into partitions. So for example, when we are creating a topic in any Kafka cluster, we have to specify how many partitions this topic should have. So the topic partition means partition is the place where this topic physically stores the data. So for example, see in my computer, in our computers, we are having this right? When I open my hard disk, I can see C drive, E drive, F drive. So in my computer, my entire hard disk is having 500 GB. So each and every hard disk, I am again partition into C drive, E drive, F drive. So this is a partition of the drive. This is a partition of my drive. This is another partition of my drive. So each and every partition is having some data, right? Same like in Kafka also, in Kafka topic also, there is something called a partition inside the topic, where this partition will be having the particular data. So each partition in topic is ordered, like each and every partition is ordered. So each message in the partition get an incremental ID called offset. For example, if any message got pushed into topic and got pushed inside the partition, then it will be having an ID. That particular message will be having an ID. So that ID is called as offset. So the word offset refers to a message. So when I say one offset, it means one message. When I say 10 offsets, it means 10 messages. When I say 100 offsets, it means 100 messages. So a message is the data that is being published by the producer, and whenever that message is loaded into the topic partition, Kafka will assign, okay, this is the ID for this message. So that ID, we are going to call it as a offset. So one message will be having one offset, means one message is having only one ID. It means one message is having one offset inside the partition. It means initially topic, then inside the topic there would be partitions. Whenever message being published into partition, Kafka will assign a ID to that message, and each and every message will be having one unique offset. So for example, in Kafka cluster, I have a topic. Let's assume this topic can have one partition or two partition or three partition or 10 partition or 100 partitions also. While you are creating a topic, you can decide how many partitions my topic should have. Let's assume in this case I have decided 3 partitions. So you can go with the one partition also, you can go with the 2 partitions also. But here let's assume I'm going with the 3 partitions. Now I will tell you in which case you will go with only one partition, in which case you will go with the multiple partitions. I will come to that. So for example, in this case I have 3 partitions. So whenever, okay, let me open a pen. So whenever an application published the message to this topic, now Kafka decides this message should go to this partition or this partition or this partition. Here we have 3 partitions, say partition 0, partition 1 and partition 2, right? So always the partition count will start from 0 in the system language, in the computer language, not from 1. Okay, so partition 0 is first partition, partition 1 is second partition, and partition 2 is third partition, total 3 partitions. So whenever any message being published into Kafka topic, so Kafka will decide that message should go to partition 0 or partition 1 or partition 2. Let's assume initially Kafka internally decided that, okay, that first message should go to partition 0. It means that message will be having an ID. ID is 0. Here 0 is an offset. And whenever messages are keep on writing into partition 0, first message is getting an ID called 0. This ID is an offset. Now second message got an ID called 1. That ID is another offset. Third message, ID number 2. It's an offset. Fourth message, ID number 3. So it's another offset. Like this, we have total 12 IDs, incremental IDs. It will sequentially it will be increased. Starts from 0 and then how many messages are that being published, based on that IDs will be allotted. So one ID you call it as offset. So in partition 0, there are 12 offsets. It means there are 12 messages. Let's assume some messages are published into partition 1. So it is having 8 offsets. It means 8 messages. Let's assume some messages are published into partition 2. So it is having 10 offsets. It means there are 10 messages. Now, come to your question. For example, let's assume there is a Kafka topic. And let's assume its topic name is TP1 and it is having only one partition, say partition 0. Okay. For example, one application has published a message to this TP1 and TP1 is having only one partition. So ultimately Kafka will put the message into this topic only. So it is going to get the IDs, right? It is going to give the offset numbers like offset 0, offset 1, offset 2, offset 3, like sequentially message will be published, right? Now an application is consuming the messages from this topic and this topic is having only one partition. So message will come in the orders. So for example, an application, a producer application published message number 1. So that message number 1 is here in offset 0. Now it has published message number 2. So that message is in this offset. Whenever receiving application is consuming the message, first it will consume message number 1. Now it will consume message number 2. Now it will consume message number 3. Like what is the order the data is being published, in the same order the data is going to be consumed. That's what the advantage when you have only one partition. If your application is having dependency of message ordering, then you must go with the one partition only. So for example, if your application, your sending application and your receiving application have a dependency of processing in the message order, like for example, if sending application has published in message number 1, then receiving application has to consume message number 1 only. Right. Now next message is message number 2, so it has to consume in 100. Second message must be message number 2. It is not going to be message number 3 or message number 4. It has to be message number 2, which is in the second position. Now third message number 3. Now there is an order. When message comes in this particular order, then only your receiving application is going to process that message. If you have such kind of dependency, then you must go with one partition only, because when you have one partition, then there is a guarantee of message ordering. Whatever the order that message is published into Kafka, in the same order, the receiving application is going to consume the message. Right?
Right.
For example, let's assume more than one partition. Say right now here we have three partitions in this case: partition 0, partition 1, and partition 2. So let's assume sending application has published 100 messages from message number 1 to message number 100. So out of 100 messages, let's assume 33 messages are in partition 0, 33 messages are in partition 1, remaining 33 messages are in partition 2. Now, a receiving application is consuming all these messages. When it is consuming all these messages, so there are three partitions, right? Now there is no guarantee of the order. So definitely it will consume 100 messages, but there is no guarantee of the order. For example, initially it may get message number 3, then it may consume message number 51, then it may consume message number 1. Like this it will consume. It will not come in an order like message number 1, message number 2, message number 3, message number 4 till message number 100. No, this is sequential order. There is no guarantee because we have multiple partitions. So the thing is, when you have a dependency of message ordering, then always go with create topic with one partition only. But the thing is, the performance would be bit higher when you have more partitions. The performance would be bit lower when you have only one partition because message should be published in a sequential order. But here, whatever the partition is free, Kafka will automatically send the message to that particular partition so that the stream would be much faster. The producing and consuming would be much faster. But here, there would be bit slow, but there is a guarantee of the messages. When you have lower messages like 100, 200, 1000 messages, 10,000 messages, that's okay. You don't feel much difference. But when you are sending terabytes of data, then you feel like difference. Now, offset of a partition. You already got a clarity what is meant by an offset. One offset, simply we can say one message. For example, say here, Kafka topic with 3 partitions. Partition 0 is having 12 offsets. It means 12 messages. Partition 1, 8 offsets. It means 8 messages. Partition 2, 10 messages. It means 10 messages. That's all. So offset only has meaning for specific partition. For example, offset number 3 of partition 0, it is having meaning to this partition only. And offset number 3 of partition 1, it is having meaning to this partition only. Offset number 3 of partition 2, it is having meaning to this partition only. So it doesn't mean that offset numbers are equal. It means the data that is being published here and the data that is being published here, they are not same. Definitely they are different messages. So this offset belongs to which partition? Partition 1 only. So it's a different data, it's a different data, it's a different data. So for example, offset 3 of partition 0 does not represent the same data of offset 3 in partition 1. So offset 3 of partition 0 does not be the same data of offset 3 of partition 1. Definitely they are different data, different messages. So data order is guaranteed only within a specific partition. So the order of the data, right, that is guaranteed only in a specific partition. So data is kept only for limited time. For example, whenever data is published into Kafka topic at the back end, those messages will be stored in the partitions. So whenever messages are there in Kafka topic, so there is a specific time span. Till that retention period only, message will be there in Kafka. After that retention time, message will be auto deleted. For example, by default, how Kafka behaves is whenever a message is being published into Kafka, by default, till 1 week, data will be preserved into Kafka topic. Till in this 1 week, the receiving application has to consume the data, and it can consume millions of times till this 1 week, because how many times it consumes till the retention period, data will be there. Retention period in Kafka means how much time data will be preserved in your Kafka file system. And the default behavior in Kafka is 1 week. After 1 week, definitely your data will be vanished from Kafka. So you can alter this, you can decrease it, you can increase it based on your business requirement. If I want to put it for 14 days or if you want to put it 30 days, of course, you can definitely do that. For that, we have to modify the configuration from Kafka side that we'll see in future classes. So once data is put into in a partition, it can't be changed. For example, whenever any message is published into Kafka partition, into Kafka topic partition, that's it. You can't change it. So data is assigned to a partition randomly. For example, whenever a message is being published, so that can go to this partition, or that can go to this partition, or this can go to this partition. So we do not have any control over it, but Kafka internally takes this kind of load balancing. So whether it should go to partition 0, or it should go to partition 1, or it should go to partition 2, it is not in our hand. Now let's talk about a broker inside Kafka. So what is broker? Let's see that. So a broker is a server where Kafka is installed and running. For example, there is a Linux server, and in this Linux server, I have installed my Kafka and I have started Kafka cluster also. It means it's now a broker. So in Kafka world, broker means it is a server. It's a physical virtual server where our Kafka is running. That's it. So Kafka cluster is composed of multiple brokers. When you take any Kafka cluster, it can have one server or it can have multiple servers. It means it can have one broker or it can have multiple brokers. A broker in Kafka cluster is identified by a unique ID. So whenever a broker is running in Kafka cluster, it means that particular broker is identified by a ID. So it is not identified by the server name. For example, when there is a server, definitely that particular server is having a host name, right? So whenever you added that server into Kafka cluster, so we call that server as a broker, and that broker is having a ID. Like in Kafka server properties file, we are going to configure the broker.id. So we will give a ID. It is any integer, any number. So Kafka cluster identified by your broker by its ID, not by its host name. So when we are installing single node Kafka cluster, there I'm going to explain you how to assign a broker ID to a server. So each broker in Kafka cluster contains certain topic partitions. For example, one Kafka cluster is having, let's assume it is having 5 brokers, because it's a multi-node Kafka cluster. It means it's having 5 brokers, 5 servers. So each and every broker contains certain topic partitions. For example, I have created a topic TP1 with 3 partitions. It means one partition will be another one broker, second partition will be another broker, third partition will be another broker. It will be segregated like that. So which partition of the topic will go to which broker, that is again not in our hand. We do not have any control over it. From Kafka admin perspective, we can just give a command of creating a topic with these many partitions. That's all. We do not have any control. This topic partition should go to which broker. No, we can't decide that. Kafka will internally manage that. So after connecting to any broker, you will be connected to the entire Kafka cluster. For example, I have a Kafka cluster with 5 nodes, 5 brokers, broker 1, broker 2, broker 3, broker 4, and broker 5. And an application people wants to put a message into your topic. Let's assume I created a topic with some partitions, say 3 partitions. And if an application, the producer application wants to put a message into the topic, so what it will do is, out of 5 brokers in this entire Kafka cluster, it can use one host. It is not mandatory that it has to use all the host of all the broker names. No, not needed. When it can use one broker, that's it. It means that connection will be distributed the load to all the brokers inside the Kafka cluster. Again, Kafka will take that load, so you no need to worry about it. So generally, a broker holds the topic. For example, when we create a topic, physically the topic file system will be created inside the broker only. So what is broker? It is like a Linux server only. In the server, we have a storage, we have a file systems, right? Inside the file system, that particular topic will be created. Now let's see, how does a broker hold the topic? It's very simple. See this diagram. For example, I have created a Kafka cluster. Like I have a Kafka multi-node Kafka cluster with 3 brokers. It means 3 servers. So first server is having a broker ID 101, second server broker ID 102, third server broker ID 103. It means 3 brokers are having unique IDs in one Kafka cluster. So this is like Kafka cluster. Okay. Let's assume I have created a topic called topic K. Topic name is topic K, and it is having 3 partitions. And for topic A, partition 0 has gone to broker 101, and for topic A, partition 1 gone to broker 103, and partition 2 gone to broker 102. So one topic, 3 partitions. Each and every partition is equally distributed to all the brokers. So which partition of that particular topic should go to which broker, that we can't control it. So Kafka internally decide, okay, you go to this part, this broker, you go to this broker. So it will be internally managed. Let's assume I created another topic, say topic B, with two partitions. So for topic B, partition 0 has gone to broker 102 of the cluster, and partition 1 of topic B has gone to broker 101 inside the cluster. So this is how the partitions, the topic partitions will be managed by the broker. So the data is distributed, and broker 103 does not have any topic B data. For example, if you see broker 103 does not have any partition of topic B, because topic B created with the two partitions, and two partitions are allotted in broker 1 and broker 2. Broker 101 and broker 102. For broker 103, it doesn't have any representation of it is not storing any physical data of topic B, because done, your out of three brokers you created only two partitions and it's allotted. Now let's talk about something called replication factor of a topic. So in the previous slides we have seen about partitions, right? Now we are going to discuss about the replication factor of a topic. So this replication factor of a topic is also another important property of a topic. So a topic, when you are creating a topic, right, even in the real time, you need to take care of two things. Number one, partitions, that we already discussed some time back. Now we are the second important thing is a replication factor. This is another important thing while we are creating a topic. So let's see now what is meant by a replication factor in the topic. A replication factor is a number that indicates number of copies of a particular topic. For example, when you are creating a topic, how many replicas you should have for that particular topic inside your Kafka cluster. For example, while I am creating a topic and I have given replication factor 2 of the topic, it means the topic will be having two replicas. One replica in one broker, one replica in another broker. So that if one broker goes down, another broker will be having to serve your data. So we'll see that with the diagrams. So for example, if a topic is created with the replication factor 3, it means topic is created only once, but it will be having two more additional copies, because total replication factor is 3. One copy you create with the command. So what Kafka will do is, as it is having replication factor 3, fine, make another two replicas, so that entire replication factor will match to number 3. So this is for fault tolerance purpose. So we have already seen Kafka has the greatest advantage called fault tolerance. It means although one instance is down, another instance of the cluster can serve your application. So see, fault tolerance is a property that enables a system to continue operating properly in the event of a failure of some of its components. Topic should have replication factor always greater than 1. So in Kafka, what is the recommended standard is, when you are creating a topic, especially in the production, always make sure you should have replication factor greater than 1. Could be 2 or 3. 3 is really a good number. Even never go with the 2. When you have multi-node Kafka cluster with 3 brokers, then go with the replication factor 3, so that although 2 systems are down, third system will be available to serve your application. So this way, if a broker is down, another broker can serve the data. For example, see this diagram. So I have a Kafka cluster with 3 brokers: broker ID 101, broker ID 102, broker ID 103. Right? For example, I have created a topic called topic A, and it is having two partitions. Say partition 0 and partition 1, because I have given partition count is 2. And also I have given replication factor 2. It means each and every partition of the topic will be having two replication factor, will be having two copies. For example, if you see this diagram, broker 101 is holding partition 0 of topic A, and also we have decided that this topic should have two partitions, right? So partition 0 is there. Now partition 1 is in 102. Fine. But we have given replication factor 2. It means each and every partition should have another copy. So partition 0 of topic A, one is already we created in 101, and another will automatically Kafka creates in another broker, which is in 102. In this case, it is created in 102. And also for partition 1 also, one copy is created with the help of command. And remaining with the help of replication factor 2. Okay, it should have another copy. So what Kafka will do is, it will create another copy of partition 1, either in broker 103 or in broker 101. But in this case, it is created in broker 103. So now see, topic A, partition 1 is in 102, another copy of partition 1 is in 103. Also, for topic A, partition 0, one copy is in 101, another copy is in 102. So simply we can say replication factor means having more than one replica, more than one copy of same partition of the topic. That is called replication factor. See this diagram. Let's assume broker 102 is down. Broker 102 is down, then there would be no issue for the application, because for topic A, partition 0 is available, partition 1 is available. All two partitions are available. So definitely it won't impact the receiving application. If in the case of broker, one broker goes down, but if this is also goes down, or if this is also goes down, then yes, it's a problematic. Generally, the thing is, when you have three brokers, right, in Kafka cluster, always go with the replication factor. This is highly recommended, especially in the production, so that in all the three brokers, you will be having all the replicas. Then, although two brokers are down, still one broker, all the copies are presented. That's the criteria you should go. So, and one more thing, it doesn't mean that if your Kafka cluster is having 100 brokers, then I can create a topic replication factor 100. Yes, technically it is possible, because you have 100 available brokers now. It means you can create 100 replication factor for one topic. But this is not at all recommended. 3 is really good number. When you are creating a replication factor 100, there would be network lag, there would be performance issues, because each and every broker must talk to each and every broker, because 100 replication factor, right? Whatever the message that being published into one copy, that should be replicated to all the 99 copies, which is a network lag, which is again a performance issue. So don't do that. Although you have hundreds of brokers, although you have 1,000 brokers in one Kafka cluster, always go with the replication factor 3 only. It's because 3 is really good number, even in the production systems also.
Okay.
Like, because especially in the production Kafka cluster, if all the 3 brokers are goes down, you won't sit idle, right? Definitely you do some research, you will see why broker, and you will try to immediately make the brokers up, because it's a production bus. How can you sit idle if the production broker goes down? You will get a P1 or P2 ticket. Now there is some concept of leader for a partition in a topic. Now we know that we have a clarity what is meant by a replication factor for a partition in Kafka topic. Now we need to understand what is meant by a leader of partition. For example, my Kafka cluster is having 3 brokers: broker ID 101, broker ID 102, and broker ID 103. It means that, let's assume topic A has been created with two partitions and 2 replication factors. So partition 0 is one copy of partition 0 is 101, another copy of partition 0 is in 102, and we have created another partition, right? Total 2 partitions. So one partition, 2 replication factor, done. Now second partition, 2 replication factor, done. Now what happens is, at any time Kafka decide, okay, when there are 2 copies, more than one copy of a partition, one copy of the partition will become a leader, and another copy will become in sync replica. So in sync replica means that will be keep on following that particular partition leader. So for example, the one which I made the star, right? Let's assume that has been elected as a leader. So Kafka decides which copy of partition should be a leader, which copy of the partition should be an in sync replica. That will be again decided by Kafka. We have nothing to do on it. Now see, at any time, one broker can be the leader of a given partition. For example, for partition 0, the copy which is in 101, let's assume broker 101 for partition 0 and broker 102 for partition 0. So partition 0 is now in 2 brokers. I mean, one copy is in 101, one copy is in 102. So now 101, here in this case 101 has been decided for partition 0. Okay, you become the leader. Broker 101 is the leader for partition 0, and for the partition 0, broker 102 is the in sync replica. For partition 1, broker 102 has been elected as a leader, and for partition 1, broker 103 has been elected as a follower. It means it's a in-sync replica. Now, whenever a message is being published into Kafka topic, that message, first of all, it will be published into leader partition only, means in broker ID 101 only. So the remaining in-sync replica thing is right, that will just follow this leader. It means whatever the data that is being updated in partition 0, so he will get the data. This partition 0 asks, hey dear leader, please give me your data. I need to in sync with you. So that leader will copy the data into this partition 0. So this will be this follower partition will be in sync with your leader. So that's why this person is called as in sync replica. So at any time, one partition will be the leader and remaining all are in sync replicas. For example, I have created replication factor 3, means another partition 0 will be created in broker 103. So he will become another ISR, in sync replica. It means for partition 0, there is one leader and two followers, two in sync replicas. So this is how it should be. So only that leader can receive and serve the data from the partition. So for example, when any application puts the data, initially leader will be updated and that leader will give the data to the followers, to this one and to this one. So the other broker will just synchronize the data. I mean the follower broker will just synchronize the data. That's it. This is completely internal. So Kafka will take care of these things. So therefore, each partition has one leader and multiple ISR, I mean multiple in-sync replica. And here one more question. For example, if a leader broke down, now what happens? Right? For example, for partition 0, broker 101 has been elected as a leader. Let's assume my broker 101. What is this broker 101? It's a server only. It's a Linux server only. If the server is down due to any issue, then what happens is another in-sync replica. Right now for partition 0, we have two in-sync replicas, right? So one in-sync replica will be get the leader privileges. He will become a leader. Kafka decides, hey, this broker is down. Now you become leader. So that broker 102 will become leader for partition 0. Now he will be the leader. He will be in-sync replica. So that's how Kafka gains.